Hello everyone, thank you very much. So today we talk about PCA and EFA, right? So that is kind of thing we need to talk, PCA and EFA. So both are using for factor analysis. PCA means principal component analysis. EFA means exploratory component analysis. So these two methods we are going to use in factor analysis. First of all, what happened here is we do PCA. From those PCA extracted component we used in exploratory component analysis, which I call EFA, right? So PCA we have minimum data sets, 100 samples are okay, but EFA we should have a 200. So for that, what we do, if you are doing EFA means we should have minimum of 200 data sets we should have. We should not, if you are doing PCA in 100 means you are not going to do a EFA. That's why you should do 200 data sets in principal component analysis. Then only you can do EFA, exploratory data analysis for PCA. So let's talk about PCA only today. Principal component analysis, as earlier I have explained. So here, what happened? First thing, it is a dimension reduction technique. So write it as dimension reduction techniques. Okay, so it is dimension reduction techniques is the first you can prefer, you can say, right? And second, what happened here, large number of variables are filtered and extracted the small number of variables. Here, small number of components of variable is taken from large number of variables. Okay, so this is second point is small number of components of variables taken from large number of variables, right? And third is PCA is like questionnaires, dimension of questionnaires, right? PCA is dimension reduction of questionnaires, also you can say, used to reduction of questionnaires. Okay, questionnaire. So you have a lot of questionnaires, maybe 80 questionnaires, right? From there, this principal component analysis used to reduce the number of variables. Okay, just a moment. Yeah, we have one more missing things over here. So I can add, it should be linear, right? So PCA should be linear. We have four assumption, you can call it as four theoretical way of understanding PCA, right? First is dimension reduction techniques. Second is small number of components of variables are extracted from large number of variables. Then we use to reduce the dimension of questionnaires. So dimension of questionnaires, if there are a lot of questionnaires over there, we can use this PCA technique to reduce the dimension of the questionnaires components, right? If there is 47, you can classify as a 4 components. Then PCA should be linear, so that another aspect, it should be linear, right? So let's talk about formula, right? Y is unknown. We can call this as a dependent variable also. is unknown, we can do y equals to e11 x1 plus e12 x2 plus dot 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 e1p xb, right? So e1p x, this is the formula y1. Similarly y2, y3, we can have those formula. Here y is unknown, so we in PC we are going to find out the dependent variables. Okay, for that y is unknown. So let's talk about other aspects in this scenario. So other aspects is like PCA, principal component analysis. Suppose there is PCA, we are going to perform PCA analysis. What? 47 questions. So we reduce to 6 components of dependent variable. Okay, so we have PCA, we perform analysis of 47 variables, and we are extracting from that 6 components of dependent variable. That's what how this process runs. Okay, so let me go to the next one. For how we will identify, there is Kaiser rule is there. According to him, 1 or 1 plus eigen value is accepted. Okay, there should be 1 or 1 plus values, eigen value, those are accepted in principal component analysis. Okay, this is the most one. So we, on other alternative, we have elbow plot. Here, wherever the bend is there, right? So in that bend, those values are taken for the analysis, right? So these two things we need to remember. According to the Kaiser, 1 or 1 plus eigen value is accepted. Below that, we are not going to accept those value for principal component analysis, right? Other one is elbow plot. So elbow plot, first bend is first bend, those bend near value are taken. Okay, this is what the formula, right? So we need to understand those formula. So we are going to reduce the dimension of question. Maybe dimension means there are 47 47 criteria is there, right? Where we are just reduce their dimension to maybe 6 components, right? We are finding out the dependent variable. Those things are here in PCA. Thank you very much.